Hi, good evening. Welcome to Unacademy. Myself Sudheep Kumar, working as a maths faculty. So today we are going to discuss about three-dimensional geometry, right? So before going to start it, let us see this. So here it is, Unacademy Plus. Are you Plus subscriber of Unacademy? So if you want to become Plus subscriber of Unacademy, first you should know the benefits of Unacademy, right? If you know the benefits of Plus, you'll become there's a chance to become a Plus subscriber. మనకి ఏదైనా బెనిఫిట్స్ గురించి తెలిస్తే కదా మనం సబ్స్క్రైబర్ అవ్వాలా లేదనేది చూసుకుంటాం, రైట్? సో బెనిఫిట్స్ ఆఫ్ ప్లస్. ఫస్ట్ వన్ is premium content at affordable price. And next, structured live courses plus dedicated live doubt clearing sessions. Next, quizzes at regular intervals for self-analysis. And then batches for complete preparation. Test series for DPPs, full length mocks, etc. with analysis. A single subscription for unlimited access. Right? So everything under single plus a subscription. So here 20 plus top educators, 10 plus batches, and 250 plus courses. There are 2000 plus lessons and many more added every day. So if you want to become plus subscriber or learning active learner, so please use the code SUDHEERLIVE, Sudheer Live, right? Thank you. So before going to start the three-dimensional geometry, so three-dimensional geometry is nothing but the extension of two-dimensional geometry, right? So as we know the two-dimensional geometry, let us see this. సో దీనికి కొంచెం ఎక్స్టెన్షన్ తీసుకుంటే త్రీ-డైమెన్షనల్ జియోమెట్రీ కూడా చేయొచ్చు. సో అది x యాక్సిస్, y యాక్సిస్. సో ఇట్ ఈస్ origin, y dash and x dash. As you know that this side all are positive values, 1 2 3 4 5. Left side of origin is -1, -2, -3, -4 and -5. Similarly, here also it is 1 2 3 4 5. If you move downwards, it is -1, -2, -3, -4 and -5. Isn't it? So based on this, these two lines divides the plane into 4 regions. Each one is called quadrant. The quadrants will denote in anti-clockwise direction. This is Q1, Q2, Q3 and Q4, right? So in the first quadrant, both also positive. X-axis value is this side as well as y coordinates also. In the second quadrant, x is negative, y is positive. And here third quadrant, x is negative as well as y is also negative, right? In fourth quadrant, x is positive and y is negative. If you go to the three dimensions, so see that three-dimensional geometry, slightly extension. If you extend it, we'll get this result, right? So this dotted line, we could not show that on the paper. It is perpendicular to the x and y axis. Suppose let us take this is x axis and this is y axis and z axis. Here it is origin. The point of intersection of three axes is origin, right? So in this case, how we'll find the signs of the coordinates? So here it is easily, it divides 8 quadrants. So in these 8 quadrants, so let us take this is Q1, Q2, Q3 and Q4. Here it is Q5, Q6. Next it is hello, good evening. So Q6 and let us take this is Q7, Q8, right? So first, as we know the two-dimensional geometry, let us write the same ordered pairs. One is positive, positive, and the next one is positive, and the second quadrant is negative, positive, right? So this is negative, positive. In third quadrant, as we know that this is negative and negative, and the next one. So the next one is this is positive and negative, right? Similarly, if you go to the remaining also, first write as it is positive, positive, negative, positive, then negative, negative, and positive, negative, right? Then let us take this as in the uppercase 4 quadrants. Let us take positive because this third axis divides the when these two divides in this plane, the third one is divides into upper part and lower part also. So we'll get upper part, let us take all are positive, and the lower part take it as negative. That's it. So this is the way we can find out easily all the quadrants, signs of the quadrants of all these 8 also. సో 8 క్వాడ్రంట్స్ డివైడ్ చేసాయి కదా 3 యాక్సిస్. వీటిలో కోఆర్డినేట్స్ అన్నిటికీ కూడా సైన్స్ ఎలా సెట్ చేసుకోవాలంటే మనకు తెలిసిన దాని నుంచి తెలియని దానికి వెళ్తే ఈజీగా ఉంటుంది కదా. సో 2 డైమెన్షనల్ జామెట్రీని స్టార్ట్ చేసాం. సో వీల్ గో టు ద 3 డైమెన్షనల్ జామెట్రీ. సో ఫస్ట్ క్వాడ్రంట్ all are positive. Second quadrant, x is negative, y is positive, z also is positive. Next, third quadrant, x is negative as well as y is also negative, z only positive. Then fourth quadrant, this is positive, x is positive, y is negative, and z is positive. In fifth quadrant, so x is positive, y is positive, z is negative. Sixth quadrant, x is negative, y is positive, so z is negative, right? And seventh quadrant, all are negative. And eighth quadrant, x is positive, y is negative, as well as z is negative. This is the way easily we can put the signs for three-dimensional, all the points. సో అన్ని పాయింట్స్ కూడా సైన్స్ని ఈ రకంగా ఈజీగా మనం చేసుకోవచ్చు, రైట్? నెక్స్ట్ ఏం చేసాను చూసారు కదా, ఫస్ట్ 2 డైమెన్షనల్ చూసుకుంటాం, ఆ 2 డైమెన్షన్ని కొంచెం ఎక్స్టెండ్ చేస్తాం 3 డైమెన్షన్కి, అంతే అయిపోయింది. నెక్స్ట్ so now we are going to see the direction cosines or point. Now let us take the point in the 3-dimensional. 2-dimensional geometry, we know that how to take the point. So if we take this one 2-dimensional geometry, suppose, then we'll go to the extension for 3D also. So when it is x-axis and y-axis, if there is a point P, x comma y, so x comma y in the sense the perpendicular distance from y-axis to the point is known as x units, and we'll write it as x coordinate, and the other one is the perpendicular distance from x-axis to the point is known as y coordinate, right? So they're also same. If we take 3-dimensional geometry, let us consider this is x-axis, this is y, and z-axis. So there is a point P, x comma y comma z, right? Here it is so if you see this one, till this it is x coordinate. Suppose the distance from the horizon to that, and here it is y coordinate, and it shows z coordinate. That's it. So like that we can represent x, y, z, a point in the plane in 3-dimensional geometry. Now let us take, if we draw a line, suppose let us draw the third one also. So we'll consider it as x-axis, and it is y-axis, and it is z-axis, right? Let us draw a line. If we draw a line, suppose it is L. The other side also extending along with that, no? So it makes angle with x-axis is alpha, with y-axis is beta, and with z-axis is gamma. right? If you take this one, we know that if a line makes angle here alpha means with x-axis, the other side it is 180 minus alpha, right? Similarly, when we draw a line in 3D, so we'll get two types of angles, supplementary angles. One is beta means other side is 180 minus beta. So alpha, beta, gamma are the angles made by the line L with the x-axis, y-axis and z-axis. Its supplementary are 180 minus alpha, 180 minus beta and 180 minus gamma. So the angles made by the line with the coordinate axis, if we take the cos ratio, then we'll call this as direction cosines. So direction cosines of line L are, one is cos alpha, cos beta and cos gamma, right? Next one is another side we will take it as cos of 180 minus alpha, cos of 180 minus beta and cos of 180 minus gamma, right? So cos of 180 minus alpha. So these direction ratios also will denoted by the letters L, M, N. L is cos alpha, M is cos beta and N is cos gamma. So here it is cos 180 minus alpha. Cos 180 minus alpha in the sense that is minus cos alpha. So this is minus L, this is minus M, this is minus N. So the direction ratios, direction cosines of, we'll write shortcuts this is of line L or plus or minus L, plus or minus M and plus or minus N, right? So here this is what direction cosines, right? So then let us go to the direction ratios. So what is made by direction ratio? So direction ratios. What are these direction ratios? If we take any values, suppose let us take the real numbers A, B, C or three numbers which are proportional to this direction cosines. Means L by A equal to M by B equal to N by C. So A, B, C are any real numbers we can take, but it should satisfy the condition. Condition satisfy all and the L by A equal to M by B equal to N by C. అయినట్టు ఏ వాల్యూస్ అయినా ఏబిసిలని డైరెక్షన్ రేషియోస్ అని అంటాం, right? Using this, when these three are same, then we can write this as L by A equal to M by B equal to N by C equal to, suppose take it as lambda, the constant value. So say this as lambda. Then we can write this as L equal to A lambda, M equal to B lambda and N equal to C lambda, isn't it? Next, So we know the result is L square plus M square plus N square equal to 1. So sum of the direction cosines of line is always 1. So how it is, we'll see that. So L square, here let us finish this. L equal to, we can substitute A lambda, right? So the A lambda అయితే A lambda whole square plus B lambda whole square plus C lambda whole square equal to 1. Then expand this. This is A square lambda square plus B square lambda square plus C square lambda square equal to 1. So lambda square take common. Then it is A square plus B square plus C square equal to 1. Isn't it? So lambda square equal to 1 by A square plus B square plus C square. Then lambda equal to plus or minus square root of 1 by A square plus B square plus C square. This is nothing but lambda equal to plus or minus 1 by square root of A square plus B square plus C square. Isn't it? So now this lambda value we are going to substitute in this one. So we got this result L equal to A lambda, M equal to B lambda and N equal to C lambda, right? So let us write that. If we substitute in that, then we get this result as therefore L equal to plus or minus A by square root of A square plus B square plus C square and M equal to plus or minus B by square root of A square plus B square plus C square. Similarly N equal to, what will get my N value? So N value is equal to plus or minus C by square root of A square plus B square plus C square. So this is the relation between the direction cosines and direction ratios. So direction ratios are of line are two pairs. One pair of values will get it. But when it comes to the direction ratios are infinite. Right? Infinitely many sets of direction ratios will get it for a line. Now suppose a question is given, a relation between these, based on the relation between these two. Hi. If you see the relation between these two, suppose the direction ratios of A equal to 2, B equal to 3 and C equal to 5. Then DCs of the line are. These are DRs of lines. Then DCs of line are. So we can substitute in that. L equal to, first find this root over A square plus B square plus C square. So root over A square plus B square plus C square equal to square root of 2 square plus 3 square plus 5 square. That equal to square root of 4 plus 9 plus 25. Hi, good evening, Sujata. Then the result is, this is 34, 38. So square root of 38. That is square root of 38. Then the direction ratios are L equal to plus or minus 2 by root 38. And M equal to plus or minus 3 by root 38. And N equal to 5 by plus or minus 5 by square root of 38. That's it. Right? Then, so we'll see the relation between direction cosines of a line. So the next one is direction cosines, relation between direction cosines. Direction cosines of a line. Right? So here, if we take these three axes, let us take x-axis, y-axis and z-axis. So there is a point P, x comma y comma z. So draw a line which is passing through the origin through P. Right? So here x-axis, in the sense this is still is x coordinate. Then it makes angle alpha. So draw a line parallel to this RS. Suppose if we take this triangle can be expressed in this form. Right? This is O, it makes angle alpha, and it is A, it makes angle 90 degree, and this is P. Right? Let us find direction cosines, we have to find, right? So cos alpha is, so cos alpha is OA by OP. Isn't it? Adjacent by hypotenuse. This is nothing but this result is x units, and this is R. Now this can be written as x by R. So cos alpha is L equal to x by R. So we get this result is x equal to LR. Right? This is XLR. Similarly, if we take the remaining two coordinates, we'll get two more triangles and we can find. So M equal to Y by R. So Y equal to MR. Similarly. And N equal to Z by R. So Z equal to NR. Right? So let us take this, sum of these values. So sum of these values are, here it is, x square plus y square plus z square equal to. If we take this x square plus y square plus z square, we know that x equal to LR. So LR whole square plus y is MR whole square, isn't it? Plus this is NR whole square. So this can be written as L square R square plus M square R square plus n square r square. Let us take r square common. So this is L square plus m square plus n square. Then we know that x square plus y square plus z square, when the point is exists in the 3D, so we know that x square plus y square plus z square equal to r square. So let us use substitute the value. Now r square gets cancelled. Therefore, L square plus m square plus n square equal to 1. So this is the way we got this result as sum of the squares of the direction cosines of a line is 1. Right. So the different types of questions MCQs will discuss in the special classes. So I request you to join in the special classes to crack TS and AP EAMCET 2021 with the better scores. Right. Thank you.